Today what we are going to do is we are going to solve inequalities. Okay, we start with the basic one. I think this one we have learned in secondary school, so no problem. Then after that, right, instead of having a equal, we have an inequality sign. So equal and inequality sign, the way to do it is totally different. Okay, we'll start with this. Then after that, we introduce the absolute sign, but this time around with equal. So how to deal with it, later we'll learn. And lastly, the absolute sign and inequality come in together. So how to deal with it, okay, we're going to learn. So basically it's these three. One, inequality, no inequality, equal sign, but with absolute, absolute and inequality. Okay, we're going to learn how to solve all these equations. I'll do A first. X squared minus 3x is greater than 0. Now, if let's say we have x squared minus 3x is equal to 0, it's easy to solve. What we do is we factorize first. Then we say x equal to 0 or x minus 3 equal to 0. So x equal to 0 or x equal to 3. Now, this is what we have learned in secondary school. But now, instead of having an equal sign, we have an inequality. Okay, so how to do? The method is a bit different already. Okay, but we still need to factorize. We still need to factorize x minus 3 is greater than 0. Now after this step, right, we don't say x is greater than 0, x minus 3 is greater than 0. No. Okay, what we are going to do is we are going to draw a number line. Okay, if I let this part to be 0, x will be 0. If I let this expression to be 0, x will be 3. Now what happens is when x is 0 or x is 3, right, it causes this expression to be 0. 0 is a neutral. That means it's not negative or not positive. So if your x is 0, it will be neutral. If your x is 3, this expression will give you a 0, which is a neutral. So now we are going to test at this region here whether it's positive or negative. I know that this one is neutral, not positive or negative, but here I need to test whether it's positive or negative. So I use a value lesser than 0. Lesser than 0, I think negative 1 will be good. If I substitute negative 1 here, it will be negative 1 multiplied by negative 4. Negative 1 multiplied by negative 4 give you a 4. 4 is positive, so I put a positive sign here. Okay. Then I'm going to test at this region here, x between 0 to 3, whether this region will give this whole expression a positive or a negative sign. Okay, so I use a value, let's say 1. Okay, you can use 2, okay, but I just choose 1. It's a convenient value. 1 multiplied by 1 minus 3 is minus 2. 1 multiplied by negative 2 will be negative 2. So what I'm interested in is a negative or positive sign. So it's a negative. Okay. Use a value greater than 3, 4. 4 multiplied by 1 will be a positive. So that means if your x is less than 0, it will give you a positive values. This whole expression here, the one I boxed up, will give you a positive value. If your x is between 0 to 3, this whole expression here will give you a negative values. If your x is greater than 3, this whole region, this whole expression here will give you a positive. And we want a positive value. This whole expression, we want a positive value. So what is the value of x that give this whole box expression a positive one? Is this region here and this region here. Okay, so answer, x must be less than 0 because it's moving this direction. 0 minus 1 minus 2 minus 3 is moving this direction. So x is less than 0, or x, this region here, is moving this direction, must be greater than 3. So if your x is less than 0, this whole expression will give you greater than 0. If your x is greater than 3, this whole expression will give you greater than 0. This is how we solve a equation involving inequality. Okay, can you take this one down? Is it clear? Anyone please say something? Is it clear?
Yes.
Okay, good. If not clear, please text me, or you just unmute yourself and say something, so that I'll see whether I can explain in another way or not. Okay, let me do B. Okay, now one way that I can think of what you most of you will do is probably right you like to move this one. Don't copy first, move this one over. So 2x minus 5 is less than 1 multiplied by x minus 2. Now is that correct? Anyone want to say something? Is that correct? Okay, maybe I tell you first. It's wrong. But think what can you tell me why is it wrong? Why this method of doing is wrong? This is wrong. Why? Anyone want to guess? We did that quite often, what? Correct? When we have equal sign, 2x minus 5 over x minus 2 equal to 1, we always bring over, and this is correct. This is correct. This is correct. When we have an equal sign, this is correct. But when we have inequality, we cannot bring this x minus 2 over just like this. Want to make a guess why? Anyone?
It's not equal.
Yes, it's not equal. That's why you cannot bring over. But why is that so? Why not? Why equal sign you can bring over? If this is inequality, right, less than or greater than, you cannot just bring this one over. What is the exact reason? Not equal is correct, but why? Anyone want to make a guess again?
It has a range.
It has a range. I cannot say you are wrong. Okay, maybe I tell you what is in my mind. Now, here, x minus 2, we don't know the value of x. Okay, let's say x is 4. 4 minus 2 is 2. If this is a positive 2, you bring over, no problem. Okay, but let's say x is 0. 0 minus 2 will give you negative 2. Okay, don't write first, just listen. Let's say it's 0 is x is 0. 0 minus 2 will give you negative 2. Now when this is a negative, we bring over, this sign will change. This sign will change, correct? It's like when for inequality, it's like if I multiply a negative 1 here and the negative 1 on both sides, this one will change. This will change to less than, will change to greater than if I multiply a negative sign on both sides. So when if this is a negative 2, I bring over, this inequality sign will change. It will change from less than to greater than if I bring over the negative 2. Okay. So x minus 2 is a positive value or negative value? We don't know. In fact, we want to find out the value of x such that this whole expression can give us a less than 1. So if you ask me whether x minus 2 is a positive or negative value, I don't know. At this stage, I don't know. Since I don't know whether it's positive or negative, I cannot just bring over to the other side. Because if this x minus 2 is negative, I bring over to the other side, this one will change. This inequality sign will change. Okay. So far so good. Is this explanation acceptable to you? Can I proceed then?
Yes.
Thanks for the response. Okay. Hey, your response is really important to me. Because I don't know anyone with me or not. Okay. I'm now in the classroom talking to myself. So if you don't respond, right, I thought that I'm talking to myself. Okay. I thought the system is not working and talking to myself. So when you say yes, I actually feel very happy one. Really, really, okay. Okay, so I'm going to solve this. Now, I've told you that I cannot bring the x minus 2 over. Okay, so I cannot bring the x minus 2 over. So how to solve this then? Okay, I cannot bring the x minus 2 over, but I can bring the 1 over. This is a plus 1. If I bring over, become a negative 1. Negative 1. Okay, now again, this x minus 2 is unknown because of the x, so you cannot bring over. If let's say this is a positive 4, you can just bring over if you want to. If you know that this is a constant and it's a positive constant. If this is a negative constant, when you bring over, you have to change the sign. That's it. Okay, x minus 2, I don't know is positive or negative. I cannot bring over. Okay, so I cannot bring over. I just bring the 1 over. Positive 1 bring over become negative 1. Okay. You can, if you have problem moving this over, you can see this as 1 plus 0 lah. So when I bring the 1 over, will be positive 1 bring over negative 1. So left a 0 here. Now I'm going to combine the two fractions together. Listen and copy at the same time, so that later you will save us a bit of time waiting. Okay, remember to put bracket. So now I remove the bracket. 2x minus x will be x minus 5 plus 2 is minus 3. Okay, so the bracket is important because negative will give you positive. If you forgot to put bracket, probably you will not get a negative 3. So now we have simplified until a stage that we can't simplify already. So we have to find the point of x that give us neutral, which is neutral, that means 0. So where are the zeros? If I let this expression to be 0, x will be 3. So this is neutral. So either side will be a negative or positive region. Then I'm going to let this one to be 0, x will be 2. So this region will be neutral. So neither positive or negative. So I'm going to substitute a value of x less than 0. I think I can use 1, but I think 0 will be very convenient. If I let x to be 0, so it's negative 3 over negative 2. So give me a positive. So this region is positive. Okay. 2 point. If I use 2.5 here, negative, positive will give me a negative. Okay. Now actually if you do long enough, you'll realize once you get the first sign, the second sign will be opposite with this sign here. If this is positive, here is negative. If this is negative, here is positive. But at least try at least 2 regions to confirm your answer first. The third region, right, I'm quite certain that it's positive. Okay, you can go and try use a value of x equal to 4. Okay, so now I want the whole expression here to be less than 0, less than 0. Okay, so less than 0, so here is less than 0. So answer x must be between 2 to 3. Okay, negative will give us less than 0, between 2 to 3. Okay, no, I didn't mention this. The right hand side, right, when you do this kind of question must be 0. It cannot be any other value. Okay, the right hand side must be 0. So you see when this is a 1, right, I bring over. Okay, it's just like when you do factorization with equal sign, you always let equal to 0. If anything here, you just bring everything to the left hand side to make this side a 0. Okay, the difference between this question and the last 2 questions that we have did is there's 2 inequality. Yeah, the right hand side always make it to 0. Okay, so someone asked a question, the right hand side, is it always make it to 0? Yes, the right hand side always make it to 0. Okay, then after that you draw the number line and check the region. Okay, now this question here is there's 2 inequality. So don't worry, just do it one by one. You do this one first. So 7 less than 2 minus 5x. It's an n. This one is an n. Okay, because this expression must occur and this condition must occur and this condition must occur, and 2 minus 5x is less than 9. So I'm dealing with the inequality one by one. Okay, this one first, then this one. Okay, it's an n because it's the both condition must occur, must be greater than 7, must be less than 9. So I'm going to solve for x. Now if I solve for x, right, I have a habit. If this is my unknown, I always make the unknown coefficient positive. So to make it positive, I bring to this side. Okay. So 2 minus 7 will give you a negative 5. When this is positive, right, when you bring over, you don't have much problem. Okay, if this is negative, when you bring over, right, you have to change the sign. Okay, I hope this is clear to you. If not clear, let me know. Okay, again, this is the unknown. So I would like to make the coefficient of the unknown positive. I bring this to this side. So 2 minus 9 is negative 7, 5x. So x is greater than negative 7 over 5. So again, this is an n condition. So x must be greater than negative 7 over 5. And x must be less than negative 1. Less than negative 1, okay? So this is the range of x. Okay, so answer x must be between minus 7 over 5. Oh, there's an equal sign here. Okay, I think I should redraw this. No need to go to erase if you draw already, it's fine. Just I want to make myself very clear. Okay, x is less than or equal to -1. Less than -1. I just draw a line. X is greater than -705. -705 is here. If the fraction is very confusing to you, you just convert to decimal. So you know that this -75 is on this side, if or on this side. Okay, if -75 should be on this side. Okay, it's because it's smaller than -1. If confusing to you, the fraction, convert to decimal so that you know it's on the left hand side of -1 or right hand side of -1. Okay, so x is greater than -75, greater, and there's no equal sign. I put a hollow circle. Greater is this direction. And because it's an AND condition, I'm finding the condition that satisfied both of them, which is the intersection. Okay, I think this is a clearer working. So your x must be between -705 to -1, which is the answer. Okay, there's a equal sign because this is a solid circle, and this is a solid circle because of this inequality, equal. Okay, there's a question asked, when I from all this step here, I no need to flip the sign. Okay, you only flip the sign. Okay, maybe I should spend a bit of time explaining this. Okay, let's say 5 is greater than 3. 5 is greater than 3. This one is correct. No one should have any question on this. 5 is bigger than 3. Now, if let's say I multiply a negative on both sides of this expression, so multiply negative is -5, multiply by negative is -3. Okay. Now, the number on the right hand side is bigger, or the number on the left hand side is bigger?
Right.
Yeah, on the right is bigger. So you see now, this sign it has to change already. You have to change this sign. A greater than become a less than. See, that is the effect of negative in inequality. Okay, for equal sign, no problem. Let's say x is equal to 3, then minus x equal to -3. You know, equal means equal. Okay, no problem. But inequality, you have to be careful. When you multiply by negative on left and right, this sign has to change. This sign has to change. Okay. Similar. For here, I no need to flip the inequality because I didn't multiply by negative, or neither do I divide by negative. What I did is -5x. I just bring over. When I bring over, it's not a multiply or divide. So no need to flip the inequality. This is a +5. +5. If I bring over, right, it will not change the sign unless this is a -5. If a -5, I bring -5. If I divide to the right hand side, then I have to change the equality. Okay. Okay, I hope I've answered your question. If not, let me know. Yeah. Find the range of values of x that satisfied the inequality. Okay, so can go a bit faster already. Okay, now notice this is a quadratic. So this whole thing is called quadratic inequality. So for quadratic inequality, first have to factorize first. So bring everything to one side. Listen and copy at the same time. Okay, we do a bit faster. So after that, we can go for our lunch. Okay, then factorize as usual. Okay, so from here onwards, right, it's not the same already, not the same as when this is an equal sign. So from here onwards, you have to test the region to get the region you want. We want a negative region, but which region is negative, we don't know, so we have to draw the number line and test the region out. Okay, we have two 0 point. One 0 point is x equal to 1. Another 0 point is x equal to 4. Okay, these are the 0 point. It's neutral, neither positive or negative. So when x is less than 1, that means I like the value 0. I use the value 0 to test. 0 will give me a negative, negative, positive. Kiasu a bit, I just make sure this is negative. Maybe I use a value of 2. 2 is -2. Positive, negative, positive will give me a negative. See, positive, negative. The next one must be positive already. I'm quite sure. And I want a less than. Less than is 0. Less than 0. That means it's negative. I want this whole expression to be negative. At which region this whole expression will be negative is this region. And in this region, the value of x, right, is between 1 to 4. So answer, x is between 1 to 4. Again, now what we are doing is we are finding out the value of x that cause this whole equation to be true. So if your x is between 1 to 4, right, this expression will be true. That means if you substitute any value of x between 1 to 4, let's say you substitute 1.2 into here, you square it, minus 5 times 1.2, it will be less than minus 4. This is what we are trying to find. We are trying to solve this inequality. Solve means find the value of x that satisfies this expression, or this equation, or these inequalities. Find the range of x for which x squared is greater or equal to 6 minus x. This is pretty the same. So maybe talk less, do more. Move everything to one side. Start with the smallest value. The smallest value is negative 3. Next value is 2. So negative 4. I use negative 4 here. Negative 4 plus 3 is negative. Negative is positive. I use a 0 here. 0 is negative. Okay. And so I want a greater than is these two region. So answer, x is less than, there's a equal sign, so here my answer will have an equal sign also. Can be equal to negative 3. Okay, or okay, it's not an and, it's or. Okay, this region will be, x will be greater than 2. There's an equal sign because the question got an equal sign. It can be equal to 2. So when it's equal to 2, right, this whole expression is greater or equal to 0. Okay. Find the range of value of m for which the equation x squared minus mx plus 1 equal to 0 has no real roots. Okay. Still remember no real roots or not? That means if you draw the graph, by the way, this is a quadratic graph. If I'm going to draw the graph, it's a quadratic graph. Quadratic graph either is this way or this way. Okay, so the coefficient of x squared is positive, so it should be a smiling face. Has no real roots. That means it will never cut the x-axis. It's a smiling face and never cut the x-axis. The graph must look this way. Okay, this is a rough sketch. It didn't cut the x-axis, so no real roots. So if you remember no real roots, right, the b squared minus 4ac is, anyone?
0, less than 0.
Less than 0. Good, less than 0. Okay, so now let's write down the equation first. X squared minus mx plus 1 equal to 0. So a is 1. Okay, no real roots. B squared minus 4ac is less than 0. B is the minus m. A is a 1. C is a 1. Okay. So m squared minus 4 is less than 0. Now, if you have noticed, this is a quadratic inequalities. Okay, so it's we come back we come back to a quadratic inequality again. So we have to use the technique of solving quadratic inequality to solve this expression. So factorize first. M plus 2, m minus 2 is less than 0. Draw the number line. Let me erase this so that I have some space. Minus 2 and 2. Negative 3 will be good. Negative 3 will give me negative 1, negative 5, so it's positive. Use a value 0, negative. Okay, so that one is positive. I want less than 0, so it's this region here, less than 0. So answer, m must be between negative 2 to 2. So if you substitute your m between negative 2 to 2 into this part here, this graph, right, will never cut the x-axis. That means let's say if I have I use a different color. I try to explain the significance of the result. So you will make the learning more meaningful, instead of accepting the result and don't know what the result means, is let's say you have a expression x squared minus mx plus 1 equal to 0. You want this quadratic graph not to cut the x-axis. What is the value of m should you choose? Okay. Sometimes when I set the exam questions, right, I need the quadratic graph not to cut the x-axis. Then I have to decide on the m value. So I use this technique to tell me what is the value of m I should use in my questions. Okay. So okay, if I don't want the quadratic graph to cut the x-axis, what is the value of m I should use? I go and do the solving part. I know that my m must be between -1, -2 to 2. So between -2 to 2, I can choose my m to be -1. So let's say if my m is a -1, this quadratic graph will never cut the x-axis. Okay, so you can plot this graph out and double check it's correct. As long as your m is between -2 to 2, okay, you substitute into here, this quadratic graph will never cut the x-axis. Okay, because we say we start from the b squared minus 4ac is less than 0. That means it will never cut the x-axis. Okay, that is the significance of the result. Okay, we are moving on to the next part of this chapter, absolute values. Later we are going. Okay, we have finished this already. We have finished this already. So later we are going to learn how to solve expression involving absolute and equal, how to solve absolute and greater than or less than, how to solve. Okay, so now we are going to learn this first. Before I go into this, let's recap what is absolute expression. What is absolute sign means? I think we all know. Just a quick recap. So we know that absolute of 3, of course, is 3. Absolute of -3 is 3. Okay. The exact definition of absolute sign come from here. If you have absolute A and your A, right, your A without the absolute sign is greater than 0, then this absolute A will be just equal to A. Okay, so for example, okay, use this one as an example. My A is a 3. My A is whatever inside here, 3. Okay, absolute 3, right? Okay, my A is 3. 3 is greater than 0. 3 is greater than 0. Okay, so that means absolute 3 will be just equal to 3 if we throw away the absolute sign. Okay, if we throw away that, this is no absolute sign here. Okay, another path. Absolute A will be equal to -A if your A is less than 0. So the example I'm going to use is this. My A is a -3. -3 is less than 0. So if you throw away the absolute sign, right, you have to put a negative in front. Okay, so what happened is this. This is maybe a bit confusing. Absolute of -3. My A is -3. My -3 is less than 0 is correct. So I have to put a negative in front of the A. I have to put a negative in front of the A. Remember what is the A? A is a -3. So the negative become a positive. That's why the result is positive. Okay, this is the way how you interpret this definition. Of course, the way I refer to the definition to remove the absolute sign can be a bit confusing, but this is how you read this definition. Now, knowing how to read a definition is important. Okay, if let's say at certain point of the time you have a similar definition, you need to read, you need to make use of it. Okay, you must be able to read, just like what I did just now. Okay, so okay, let's proceed. So anyway, this is a definition of the absolute value. Okay, let's proceed. So in short, and anything after the absolute will be positive. Absolute of a positive 3 will be, if you remove the absolute sign, will be positive. Absolute of -3, if you remove the absolute, it will still be positive 3. The negative is gone. So the result is always positive. This is one important property of absolute values. Okay, next. Okay, the next one I want to tell you is this. Okay, this one you pay attention, is a bit different from what you know from secondary school. Now in secondary school, if I remember I think I was told this absolute square root of a x square. Anyone want to make a guess? What is the result? Square root of a x square. Anyone want to try?
X.
x, most of us will say x, including me before I learn absolute. Okay. Yeah, most of us will say x. Okay. Now, in fact, this is when we are in secondary school, we are told on absolute of, square root of x squared is x. Okay, it's not wrong, but it's not totally correct. It's not totally correct. Now we level up already because we know absolute value. Square root of x squared, right? Okay, is actually the equal to absolute x. Can everyone take down this? I will explain. This is the correct definition for a square root of x squared. Okay, example. Now let's say we are given square root of x squared is equal to 3. We are going to solve. We are going to solve this. Okay, so okay, square root of x squared, right? Based on this definition, square root of x squared is absolute x. So we are going to change this to absolute x from this definition. Absolute x equal to 3. Okay, if absolute x equal to 3, right? If I remove the absolute, it can be positive x equal to 3. Or if I remove the absolute, there's two cases, right? One is positive x, the other one is negative. Negative x will be equal to 3. So x equal to negative 3. So x can be 3, x can be negative 3. Now let's do a check. 3 square is 9. Square root of 9 is 3, is correct. Negative 3. Okay, negative 3 square and you square it. So it's still a 3, so it's correct. Okay, so it's correct. Okay, so remember, okay, square root of x squared is not x alone only, it's absolute x. Square root of x squared is not x alone only, it's absolute x. Okay, so if to solve this, right, I think I need to show one example on how to solve absolute x equal to 3. In fact, I've explained here already. Later I'll show you one more example. Absolute x equal to 3, if I remove the absolute in order to solve for x, right, I have to consider two cases. Remove the absolute, become a positive x. Remove the absolute, become a negative x. Okay. If I remove the absolute, become a positive x, is the case where x is greater than 0. If I remove the absolute, x become a negative x, is for the case when x is less than 0. Okay, I'm referring to this definition here. This one, absolute x can be positive. Absolute x can be equal to x if your x is greater than 0. Absolute x is equal to negative x is x if your x is less than 0. Okay, so it's positive or negative. Here, when I remove the absolute, right, it can be positive x or negative x. Okay, I maybe do one more example. Okay, how to solve. Okay, I do this example. Okay, so maybe I just say out from the solution is there. I just say out absolute x minus 2 is equal to 3. If you want to solve this, you have to remove the absolute. If you need to remove the absolute, like what I say, okay, if you need to remove the absolute, you have two cases here. Absolute a become a positive a if your a is greater than 0. Absolute a become a negative a if a less than 0. So let's remove the absolute sign. If your this whole thing will be the a, x minus 2 will be the a here. If you remove the absolute, if your x minus 2 is greater than 0, so when you remove the absolute, right, it will just become x minus 2 without a negative sign here. So I think this one start from here. Okay, x minus 2 is equal to 3 when you remove the absolute sign. Okay, that is the case where x minus 2 is greater than 0. This path here. Then if your x minus 2 is less than 0, then you have to put a negative sign in front of the expression a. So you put a negative sign in front of the expression. Remove the absolute sign, put a negative sign, then solve for the x. Solving for the x is not difficult. Okay, I think this is the part. Okay, remove the absolute sign, become this. Remove the absolute sign, the second case, now with a negative value. Okay, I think with this highlighting you'll be clearer. Okay, so this is the way to solve absolute equation. Okay, so now where are we? We have learned this. Remember this or not? We have learned this. Now we have learned this already. You have to remove the absolute sign first. When you remove the absolute sign, you have considered two cases. One is positive, x minus 4. The other one is negative bracket x minus 4. Then you solve for x. Remove the absolute sign first and consider the two cases. Last part already. Last part already. If you are bored, last part already. It's going to be over very soon. Okay, now we are going to consider the last case here. The last case is this. Okay, absolute sign with inequalities. Notice there's no equal sign now. There's an inequality. Can be greater than, can be less than. Okay, it's inequalities. Now, how to solve this? I'm going to go through. Please pay attention. I perhaps is you are tired now after 1 hour. Okay, perhaps you are tired here. But I would say this is the most important part in today's session. This is something that all of us never learned before. This is the A-level syllabus. This one perhaps if you have taken A-Maths you might have learned before. This one might or might not, but this one definitely not. Okay, so pay attention here, and I'm sure I can finish this in another 20 minutes or so. Okay, pay attention. This is the last bit already, and I would say the most important part. Okay, everyone, can you please say hi to me so that I know you are around? Hi, just say hi or okay.
Hi.
Hello.
Hi.
Hello. Or maybe from this side.
Can thank you very much. Okay. I so long I never hear your voice. I thought you are gone. Okay, good. Okay, last bit already. Absolute x minus a is less than k. Notice there is a inequality and absolute. So maybe I write down absolute and inequalities. Okay, so we are going to solve absolute and inequality come together. Okay, if you remove the absolute, right? If you remove absolute, okay, this will be the result. Okay, x minus a is between minus k and k. Now, why I will explain later. Let's accept the result first, and I'm going to do one example using this result. Why after the example, then I explain the result. Let's get the result right first. Okay, let's know how to use the result. Why later? Okay. Again, absolute x minus a is less than k. If you remove the absolute sign, the x minus a here, is between minus k and k. K is this value. Okay, maybe I do one example on this. X minus 2 is less than 3. Okay, so I write down the result. This result I no need to write down because I don't want to scroll up and down. Okay, the result is this. If x minus a, I copy from the book, so you no need to copy. You can just refer to the book. I don't want to scroll up and down. If absolute x minus a is less than k, then it's equivalent to x minus a is between minus k and k. Okay, let's know how to make use of the result first, then later I'll explain the result. Okay, so now this question here is exactly this one. Okay, less than. Okay, you have to look for less than. Okay, so if I remove the absolute, right, x minus 2 is between what? Minus k to k. Okay, what is the value of k? The value of k is a 3. So between minus 3 minus k and k is 3. So now for this case, I add a 2 to both sides. Okay, I no need to split because it's pretty easy to solve. So x is between minus 1 to 5. Okay, let me do a test of my answer. So I've found out that if my x is between minus 1 to 5, right, the absolute of x minus 2 will be less than 3. So minus 1 to 5, maybe I use 0. My x is 0. Try x equal to 0. I substitute 0 into here. 0 minus 2. It will give me this will give me 2. 2 is less than 3 is correct. 2 is less than 3. Okay, so let me try another value. I'm trying to convince you that my result is correct, but I cannot test every values. I only can test 1 or 2. Hopefully you are convinced. Okay, maybe I find a value closer to 5. 4. I use a value of x equal to 4. This one only copy if you don't want to, just for me to explain to you. X is 4. 4 minus 4. 4 minus 2 will give me a 2 also. 2 is less than 3, correct? Okay. Okay. So this is the answer. Surprisingly, it's quite easy to do with absolute and inequality come together. It's quite easy to do. You just need to remember the result. But of course, like what I always say in class, as much as we can, don't always remember the result. If you can, try to understand the concept behind it. But not not all things the concept can be easily understand. But this one I think the concept can be easily understand, and I'm going to present to you now. Okay. Proof that if absolute x minus a is less than k, then x minus a is between minus k and k. Okay, write nicely. Okay, so now I'm going to prove to you if absolute x minus a is less than k, then if I remove the absolute sign, right, x minus a is between minus k and k. Okay, I start with this first. X minus a is less than k. Now, still remember or not? Let's go back to our basic. If I want to remove the absolute, okay, to go back to our basic, okay, there are two cases here. Anyone remember the first case? If I remove the absolute, right, what will be the sign in front? Anyone?
Negative.
Sorry?
Negative or positive?
Oh, negative or positive. Okay, someone say out the two cases. Okay, so the first case will be positive. Okay, that is the case where x minus a is greater than 0. Okay, I didn't write that one down. The second case will be if I remove the absolute sign. This is a bracket, not absolute. If I remove the absolute sign, it will be a negative here. Okay, that is the definition of absolute, if you still remember. Okay, this case here will be x minus a is less than 0 based on the definition. Okay, but that information is not important here. Okay, so I didn't write down. Okay? So now I'm going to solve for this. Okay, wait, let me do it again. So this one, the x minus a is already the so-called subject of formula already. So I no need to move the a over. I want the x minus a to be subject of formula. I just need to bring over the negative. Okay, let me proceed. So I come from negative left and right. So it's negative k. But this, because I multiply by negative, this sign have to change, become greater than. So x minus a is greater. Okay, so now it's an AND condition. So x minus a must be greater than minus k, must be greater than minus k, greater than minus k. X minus a must be greater than minus k. X minus a must be less than k. X minus a must be less than k. See, this is the result given in the book. Okay, now what we have just did is to prove this expression. This is if absolute is less than k. If your absolute is greater than, I can see the difference is greater than now. Instead of less than, is greater than. Okay, then your x minus a is greater than. If when you remove the absolute sign, your x minus a will be greater than k, or x minus a is less than minus k. Now the proof for this, right? The proof for this, you do it on your own. If you can't get it right, you find out from me next week in class. Okay, the proof I will not do it. What I've did is I proved this for you. You can use the similar techniques to prove this. Okay, the second result when it's greater than absolute x minus 2 is greater than 4. So okay, class, you see how I write. Don't copy first this one. You see how I write. How you write will help you to remember. Okay. Of course, you can remove absolute sign, then consider the case positive sign or negative sign. Okay, I leave it to you. Okay. So, but I'll just use the result. Okay, so remove the absolute sign. X minus 2 is greater than 4. I'm actually rewriting this by removing the absolute sign. When I remove the absolute sign, I just rewrite this. Remove the absolute sign. Okay, so what happened if you refer to the textbook, right? this greater than sign has to change to less than. Then you insert a negative into this value here. Okay, so again, you see how I write determine how I will remember. Okay. Never mind about that. X minus 2, remove the absolute sign, everything the same. Or remove the absolute sign, switch this greater than to less than, and insert a negative 4 into here. So x will be greater than 6, or x will be less than negative 2. That's the answer. Okay. Okay, let me explain the last one, then we can call it a day already. Okay, last one, this is the questions. Again, you must learn how to identify the question. I always mention this. If you can identify the question, then you will know what method to use. There is an absolute sign here. There is an inequality. So to solve a absolute inequality, yeah, use these two results here. Okay, if you see absolute inequality, okay, use these two results here. Okay, if you don't want to use these two results, then you have to consider both cases. If remove absolute sign give you positive, remove absolute sign give you negative. By doing that, you don't need to remember the result. Okay, but it will take you a longer time to do. Either way is fine. Okay, or if you remember the result, but when you go into the exam, you suddenly forgot the result, then never mind. Use the basic, remove the absolute sign, become a positive case, remove absolute sign, become a negative case. Okay, then you work from there. You still will get the same answer. Okay, so now let's do that question. Last one. Okay, the way they do is a bit I would like to present in at least for the first few steps slightly a bit different from the text. Okay, maybe I'll do this one. Present. Okay, you listen and copy at the same time. Greater or equal to 3. Now let me ask a question. Can I can I bring can I bring this one? Okay, before you answer the question, you think first. Before you answer the question, you think first. Can I bring the absolute of 2x minus 3 to this side? That means 2 is greater or equal to 3 multiplied by absolute of 2x minus 3. Can I do this? Think before you answer. Anyone want to give it a try? Can or cannot?
Cannot.
Any more? Anyone say can? No one. Okay, never mind. Okay. This is a trick question. This is a trick question. Okay. You are very brave to answer this. Very good. Very good. Okay. No matter what, right or wrong, I think we should give it a try. Then you will remember. Okay. So don't afraid to try. Okay. Earlier on, I think we have one example. I think something like this might not be exactly. I say that if there is an inequality here, you cannot bring the x minus 2 over. Because you don't know x minus 2 is positive or negative, it will depend on the value of x. Okay? Unless you are very sure this whole thing is positive, for example like this. If you very sure this is positive, bring over, no problem. But this one you cannot bring over because of the unknown x. You don't know this whole expression will give you positive or negative. But what happened here? This is an absolute 2x minus 3. Is there any chance for this expression to be negative? Any chance for this expression to be negative? Anyone?
No, 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 no.
Yeah, correct. There's no chance for this expression to be negative because so just now, let me repeat what I said just now. Because this is absolute, right? There's no chance this whole thing will be negative. So if I know that this whole thing will be positive, I can just safely bring over. This is correct. This is correct. Okay. Because like what I say, absolute, right, will make whatever inside the absolute become positive. Okay. So if the absolute, although I don't know the value of x, right, this whole thing is still positive. So positive, if I know this is positive, I can safely bring over. Now I bring the 3 over and make the absolute 2x minus 3 the subject of formula. Okay, notice this is smaller than, so it has to be, the smaller than is with the 2x minus 3. So So if I switch to the other side, this smaller than still follow the 2x minus 3. So 2/3 is with the bigger one. 2/3 is here. Okay. So now this, if we refer to the notes, right, absolute 2x minus 3 is smaller or equal to 2/3. So what is the result? The result will be 2x minus 3 is between minus 2/3 and 2/3. I'm using the part 1 of the result. Part 1 of the result. Okay. You just refer to the page on the left, page 615. Page 615. Theorem 6.8 part 1. I'm using the part 1 of the result. If this is absolute less than sign, remove the absolute, then it's between minus k and k. Okay, so now I think where are we? I think from this part onwards, right, everything is the same already. This part is the same as this one already. So I no need to write. Now, maybe I should also explain what the book are doing. Okay, after this part, I think it's not difficult already. Okay, I'm sure you know how to figure out this. Okay, maybe let me explain this quickly. Bring the 3 over to both sides. Divide by 2 on both sides. Then you get the value of x. Okay. Now, how about these 2 steps here? What the book is doing? Okay, what the book did is, okay, they flip the left and the right. So they flip this and they flip this. When you flip right, the inequality sign will change also. So for example, 6 over 3 is 2 is less than 9 over 3. Okay, 6 over 3 is less than no equal sign. Is less than 9 over 3. Because 6 over 3 is 2, 9 over 3 is 3. If you flip both left and right, okay, the inequality sign should change also. Less than become greater than. This is half. This is 1/3 only. Half is greater than 1/3. So if you flip right, the inequality sign will change. Okay, this is a property of inequality. So what they did is they flip left and flip right. The inequality sign will change. Okay, then they bring the 2 over, and this part here is the same as here already. So what I did is, instead of flipping the fraction, I just bring this one over, and I can bring over because I know absolute right is the result right will be for sure positive. And if I know this is for sure positive, I can just bring over, although this is inequality sign. No, okay. Now, if you write the final answer as this, right, you have missed out 1 point. Okay. Now, for fraction, we always check for divide by 0. Anything divided by 0 is undefined in maths. So 7 over 6. So my x is between 7 over 6 and 11 over 6. Now, okay, I need a calculator. I take out a calculator. I think this fraction is a bit, I cannot tell which one is bigger. Okay, if I convert to decimal, 7 divided by 6 is 1.16. 11 divided by 6. I'm pressing my calculator, 1.83. Okay, so now, okay, 2 divided by absolute 2x minus 3. So if I let 2x minus 3 equal to 0, x will be equal to 3 over 2. 3 over 2 is 1.5. 1.5 is between 1.16 and 1.83. Okay, I'm saying. So this, when x is 1.5, when x is 1.5, it will give you divide by 0. So 1.5 is here. Okay. So okay, if you remember by working out the working, my x is between this value and this value. That means between 1.16 and 1.83 must be between. There's an equal sign, so solid circle. Now it's between this to this, but it cannot be 1.5, because when it's 1.5, right, it will cause this expression to be divided by 0. So x cannot be 3 over 2, 1.5. Division by 0 is not allowed. Okay, so this one is this value is not included until here. So I think, did they write down the set builder notation? Yeah. Okay. So the exact answer is 7 over 6 until 1.5, 7 over 6 until 1.5, which is 3 over 2, can be equal to 7 over 6, cannot be equal to 1.5. This is a round circle. Union with 1.5, 3 over 2, all the way to 11 over 6. Union with 3 over 2 cannot be equal, so it's a round circle all the way to 11 over 6. Now, if you don't want to write in interval notation, you can just write this. Your x must be between 7 over 6 until 3 over 2, or cannot be equal to 3 over 2. There's no equal sign here, because 3 over 2 will give you a divide by 0, until then another region will be 3 over 2 until 11 over 6. 3 over 2 until 11 over 6 cannot be equal to 3 over 2. Okay, that's all for this question. Okay. So just be careful. If you have a fraction, always check for divide by 0 and exclude the answer. If the value of that divide by 0 is part of your answer, you have to exclude the answer from your answer you have found out earlier on. Okay. Okay. We have finished what we need to do, but before we go, I would like to take 5 minutes to have a quick summary of what we have learned. Okay. Very fast one. Very fast one. Okay. So let's summarize what we have learned using this 4 example. Okay. This one should be easy. The first one, x squared minus 4 equal to 0. So x plus 2. This one not to copy. You just sit back and relax. So because they are equal sign, you can just say x equal to -2 or x equal to 2. This one should be easy. B, now we have an inequality. So what we do is, then after that, anyone remember what should we do next? We should draw a number line. Okay, so it cross at 2, -2 and 2. Then we use a value of x less than -2. Let's say -3. So -3 plus 2 is -1 times -5. -1 is positive. So use a value of 0 to test negative, then it's positive. So we want greater than. Greater than is these two regions. So your answer for x is less than -2 or x is greater than 2. Okay, this is a summary of what we have learned. Okay, then the next one, absolute and an equal sign. Absolute and equal sign, right? What should we do? We should consider two cases. X minus 4 equal to 3. Remove the absolute sign. This is a positive. The second case will be remove the absolute sign. And here will be what? Anyone?
Negative.
Negative, yes. Okay. Okay. So now, after you remove the absolute sign, we solve as usual already. Now, until this stage, right, this is quite the same as this already. Okay. So for this case, no need to factorize. Just x only. So it's 7. X minus 4 is -3x will be equal to 1. Okay. Now, I personally think this is a very good summary of what we have learned. It combines all the possible equation into one page. You are supposed to know how to solve in one page. So it's very good for learning. Okay. But I think now year 3 already, you should know that after you study everything, if you can summarize what we have learned, it's very effective. Okay, that means you know the topic very well. Summary is important. Okay, maybe I change it to 3. Okay, so remove the absolute sign. Everything will be the same. Remove absolute sign. You switch this sign, become a -3. 4 less than 1. Okay. Cool. I think we have finished what we need to do. Right, if you have no questions, right, you can you please just say bye to me, then you log out from this chat room.
Bye.
Bye.
Bye. Thank you.
And goodbye.
Thank you, Joe.
Bye. Thank you.
Bye.
Around. Okay, good. Great.
See.
Okay, by the way, I'll this session I will post it in Blackboard lah. Okay, I'll let you know once I've did that.
Okay, thank you very much.
Everyone.
谢谢，拜拜。
拜拜。